Today I'm here to explain about this question. Prove the following limits. Limit as x approaches 0, x squared times sine 1 over x is equivalent to 0. This looks a little bit easy for you, but it's a bit tricky because probably you're going to plug in 0 into this function, but in mathematics you can't plug in 0 in denominator in fraction. So it cannot be like that, 1 over 0. Yeah, but you have 1 over x here, so it's going to be like that. So you can't just simply plug in 0 into x. That's the problem. So what would you do? So what you have to use is squeezing theorem. Have you ever heard of it? Squeezing theorem. Let me simply explain about it. If you have some unknown function which is just unknown number, which is for example b, if this one is bigger or equal to 2, and if this one is smaller than or equal to 2, b is definitely going to be 2, right? This is squeezing theorem. So to find the value of this one, you try to find the equation like that, or the bigger or smaller thing. Then you try to find the value of this one. Let me explain using this question. First of all, you don't start from x squared times sine 1 over x. You start from sine 1 over x, because you can just simply write like this. You know why? Yeah, because sine curve is always like this. If there's no the value here, the maximum value is going to be 1 and minimum value is going to be -1. That's why sine something is always bigger than, it's between -1 and 1. So let's start from here. But like this function says, you want to find this function. So let me try to make it closer to like this. So let me multiply x squared for everything. It's going to be -x squared and x squared times sine 1 over x and x squared. Now it's getting similar. Then what I'll do is using squeezing theorem. I try to find the limit of these two. Let me do that. Limit as x approaches 0, -x squared, which is 0. We can just simply plug in 0 here because it's not a denominator. And also limit as x approaches 0, x squared is equivalent to also 0. So now you got this one is 0 is bigger than 0 is x squared sine 1 over x is bigger than or equal to 0 or smaller or equal to 0. That's why limit as x approaches 0, x squared sine 1 over x is 0. Now it's proven. Oops. Okay. So let's work on one more question then. The question is limit. Okay, let me find the question. Limit x approaches infinity, sine x over x is equivalent to 0. So let's use squeezing theorem again. So first you start from sine x. Yeah, in this case you usually start from sine, cosine, or tangent, something like that. Again, this is between -1 and 1. Then this function has over x, so let me divide by x for everything. Then -1 over x and sine x over x and 1 over x. And let's find the limit for both sides. Limit as x approaches infinity, 1 over negative x is equivalent to 0, because 1 over infinity is going to be 0. And also limit as x approaches infinity, 1 over x is 0. So now limit x approaches infinity, sine x over x is going to be 0, based on the squeezing theorem. Now it's proven. Okay, yeah, that's all.